The first one, these are kind of in order. So when you're looking at a factoring problem, you should always look for this first. It's called the greatest common factor. So you look at your problem. So right here, I've got the 2x squared and the 20. What could I pull out of both of those parts? And what else? An x will come out. I can also divide them by a number. What constant can I divide them? So 2x is my greatest common factor. So what you do is you write your greatest common factor, then you write a set of parentheses. And then you actually go through and you divide the original problem by your greatest common factor. I do this in my head, but if it helps for you to divide, then actually write it out. What will you have left when you divide by 2x? This is going to decrease by a power, right? The 2's cancel, and you'll just have x right here. And then plus 10. And you always can check your answer at the end using the distributive property. So if with my finger, is 2x times x 2x squared? Yes. Is 2x times 10 20x? This is factor form. This is standard form, but they're equal. So you should be able to distribute it out and get back to the original answer. See if you can try example B, finding the greatest common factor. So just can you find the greatest common factor, and then I can help you write it. So write your parentheses, and you're going to put your greatest common factor right in front of that parenthesis. What can you divide them both by? So what did you say? What was your greatest common factor? 3x. So 3x goes here. Then you actually need to divide by 3x. And the 3's will cancel. You have x cubed. You're dividing out an x. So now you have x squared left. And then here the x's will cancel, and you would just have plus 7. So 3x times x squared plus 7. This looks different than all of the rest of the problems. Usually you have 2 parentheses with 2 binomials. This is a greatest common factor with 1 binomial. So this strategy, always do it first. All right, so then if you don't have a greatest common factor, you should always look for the difference of squares. Can you list the perfect squares for me? So 1 squared is 1. What's 2 squared? What's 3 squared? What's 4 squared? Okay, then what? 25, 36, 49. Yep, 8 squared is 64. 9 squared is 81. 10 squared is 100. I mean, I'd be happy if you knew those. Anyone know 11 and 12? So 121 and 144. Those are all perfect squares. So your brain, if you're going to try to do the difference of squares, it needs to recognize these are the perfect squares, and in every problem, I'm seeing those types of numbers. So if you don't know what a perfect square is, how can you do this formula, right? I think a lot of you are pretty strong with these numbers. You've used them in geometry a lot for like Pythagorean triples. Okay, the pattern is, I'm going to write the pattern first over here. If you have a squared minus b squared, you factor it into a plus b and a minus b. So that's the official pattern or rule. And basically all you're doing is taking the square root and making one binomial a plus and one binomial a minus. So if I wanted to factor x squared minus 100, what I do is I write my 2 parentheses, and I just take the square root of each of those pieces. So x squared just becomes x times x, and 100 just becomes 10 times 10. That's it. I put 1 with a plus, and I put 1 with a minus, and it's already factored. 1 gets a plus, and 1 gets a minus. You can flip-flop them. You can put the minus here and the plus here. So that is difference of squares. I always look for that second because this is a special situation, and this is also a special situation. Most of our factoring is going to happen down here when you've got a trinomial. All right, I'm going to do the same thing on B. I'm going to write my 2 parentheses, and I have to take the square root of the 4x squared. So that would be 2x times 2x, right? So 2x times 2x. And then the square root of 25 is just 5 times 5. And then 1 gets a plus and 1 gets a minus. The reason that they get the plus and the minus, you guys remember, did you ever do FOIL or did you do the box method? How did you multiply out a binomial times a binomial? I always do my first, right? So that would be 4x squared. You don't have to write this. And then I would always do my outer and my inner. So negative 10x and positive 10x, that adds up to 0 because they're opposites. And then I would have 5 times negative 5 is negative 25. You may have not done FOIL. You may have done the box method last year. So the box method, 2x plus 5, 2x minus 5. See how I get 4x squared, negative 10x, positive 10x, negative 25 inside my box. Are one of those two methods coming back to you to multiply binomials? I don't care how you do it. Sometimes by pre-calculus, you're going to be multiplying these a lot. It's kind of nice to not have to do the box method every time if you can get quicker at multiplying them in your head. But if this is your no-fail way, do the box, right? However you can multiply these things. All right, so then this is an important thing to note. Can you factor x squared plus 9? No. What if I tried to do it? So what if I took x squared plus 9 and I tried to write it as x plus 3 and x plus 3, because that looks good, right? 3 times 3 is 9. What happens when I do my outer and my inner is I actually get 6 x's. So I get x squared plus 6x plus 9. There's no 6x up here. So this is actually a prime. It's not factorable. And the reason for that is because we're going to be finding x-intercepts. Does x squared plus 9, when I graph it, have any x-intercepts? No, it's way up here. So if you never touch the x-axis, guess what? You're also prime. You can't get factored. All right, perfect square trinomial. I think a lot of you learned the diamond method for this, but I would not use the box. To me, the diamond method is efficient enough. So what you do is, you know that you're going to have 2 sets of parentheses. You know that it's going to be x times x to give you x squared. You just need to figure out the other 2 numbers. And so what you did with the diamond is you put your 16 up in the top of the diamond, and you put the negative 8 down in the bottom of the diamond. And you have to multiply to give you the top, and you have to add to give you the bottom. So what are the factors of 16 that would add up to negative 8? So like 1 times 16, 8 times 2. Okay. The multiply, yeah, so we're doing all the factors of 16 in our head. Oh, sorry, I didn't move it over. So you multiply to 16, and you have to add to get negative 8. So a factor of 16, like 1 times 16, but that doesn't add up to negative 8. So, like 8 times 2. So, right, negative 4 times negative 4 will give you positive 16, but that also adds up to negative 8. So when you do your FOIL, you'll get your negative 8x when you do the outer plus the inner. So we need to bring back those factoring factors skills, right? You got to come up with the factors of the number. So let's set up part B. Put your 2 parentheses, right? The top of my diamond would be a 36. The bottom of my diamond is a 12. Some people like factoring because it's just like a little puzzle. So it's okay if you like it. To me, I like factoring. It's like a puzzle. How do I get it to equal itself? What are the factors of 36 that would add up to 12? 6 times 6, x plus 6, x plus 6. You might wonder why this gets its own category, perfect square trinomial. What happens when you factor these? You get the same set of factors twice. So when you see your answer on the SAT, they probably will write this as x minus 4 squared or x plus 6 squared because it's the same factor written twice. You don't have to write it like that. I would accept either answer on the quiz. But just so you know, those are equivalent because it's the same factor written twice. All right, number 4 is the same as number 3. It's the diamond method. They're just going to come out as different. I'm going to do box on the back. The box we'll do after lunch. This is, they all start with x, right? X squared, x times x. I'm looking for the factors of 40 this time that have to add up to 14. So what are the factors of 40? Like 40 times 1, 10 times 4. And if it is hard for you to come up with the factors, I would make a factoring tree. So I would start doing, okay, I can divide 40 by 1, 1 times 40. I can divide 40 by 2, 2 times 20. I can't divide by 3. I could divide by 4, 4 times 10, or 5 times 8. If you have the list, then you can go through and say which set of factors adds up to 14. So you'd write your answer. We want 4 and 10, x plus 4, x plus 10. Either order is fine. You could put the 10 first. Could you try B, C, and D and see if we can check those answers before we go to lunch so that we can work on the box method after lunch? Is this kind of coming back to you? Believe it or not, you learned it before. I know. We did. You were the virtual factoring. Yeah, so you said practice a bunch. And I was just looking at where. Is there a greatest common factor? Is there a difference of squares? Is it a trinomial that has x squared first? These all have x squared first. So you've got to practice in your head going through those steps. On every single one of these, you can set up x, x. Then you're just looking for the last 2 terms on each of these. So you could at least get partial credit just by starting to set up the problem. Yeah. Yeah. If this came out negative, right? Then one of them is positive, one of them is negative, and then you have to figure out what adds up to the. Is this coming back to you at all? Yeah. Oh, good. I mean, you guys have different strengths. So rapid might not be your strength, but that's where you make it.
Still multiply the positive with.
Okay. It's just going to take a lot. Think about this unit.
Yeah.
Right. Okay. I'm reteaching. This is reteaching method. You're just gonna have to practice it. Right? I didn't assume that you knew how to do it, and I just said, right? I showed you. So after lunch, when you have to pick the method, we'll practice. I'm gonna wait another minute to put them